Okay, I'd like to continue practicing drawing hybrid orbital diagrams. Last time we drew one for ethylene, which is a fairly simple molecule, so we're going to look at something more difficult in this video, acetaldehyde. Let me draw that for you. So this is acetaldehyde on line angle. In non-line angle notation, it would look like this. And acetaldehyde is a common functional group, and aldehyde is a oxygen double bonded to a carbon with a hydrogen. That's called an aldehyde. It's a functional group, which we'll learn about later on in the class. But anyway, and don't forget, because this is an inline angle, there's actually another carbon there as well that's not shown. Just have to assume it's there. So the first thing you want to do when making these diagrams, remember, is identify the hybridization of all the atoms involved. So this carbon right here is sp3 hybridized because it's attached to 4 different things, the 3 hydrogens and the carbon there. And because it's sp3 hybridized, we're going to have 4 sp3 hybrid orbitals, which means that 2 will be in the plane and 2 out of the plane. So we'll need to use some dashing and wedging here. The hybridization of this carbon here is sp2. That's attached to 3 different things. And there's actually 2 lone pairs on that oxygen. So that makes it sp2 hybridized as well. So when we're drawing this diagram, we'll have to take that into account. We'll also have to take into account that the oxygen and the carbon have an unhybridized p orbital. We'll have to show that with dashing and wedging as well. All right, so I'm going to move this out of the picture now and get to drawing this. And bear with me, I might have to redraw things a few times just to fit everything. But I'm first going to draw in my molecules. So I have the oxygen, the carbon, and then the other carbon. And I'm actually going to move this up a little bit. And you're going to notice that I draw things in a way that indicates 120-degree bond angles for that hybridization of trigonal planar for the carbon and the oxygen as well. So the first thing I'll draw in are the sp2 hybrids. So the carbon and the oxygen will have 3 each of those. And let me draw in the back lobes now. So remember, each sp2 lobe will have a back lobe, so that's 3 back lobes for the carbon and the oxygen. And let me label each of these as sp2 orbitals. And we have formed a sigma bond right here, so let me put in my electrons. Now I need to show that each of these, the carbon and the oxygen have an unhybridized p orbital. So one lobe will be going in the plane and one lobe will be going out of the plane. So let me draw those in now. Let me choose a darker color. So here's one p lobe, and I'm going to choose this one to be going in with the wedging. And I'll dash this one to indicate it's going away. Label these as PZ. And the carbon will also have an unhybridized p orbital, so I'll wedge this one as well and dash the other. And remember, these will overlap to form a single pi bond, so each of these will be sharing half of a pi bond. And we'll show the electrons just in one of them. That's fine. Okay, so now let me address the carbon, the other carbon rather, and that's going to have 4 sp3 hybrids. 2 of them will be going in the plane and 2 of them will be going out of the plane. So I'm going to choose to make this one dotted. I'll make this one wedged. Do the same pattern over here. Now you may have noticed that I made these sp3 hybrids a bit more narrow. That's because the sp3 hybrids have greater percent S character, so they do end up looking a bit more narrow. So you do want to keep that in mind as well. And we have formed a sigma bond here. And let me label each of these as sp3. I'll put in the back lobes now. So this one will have 4 back lobes. One there, one there, one there, and one there. And now I need to draw in my 1s hydrogen orbitals. So don't forget there's a hydrogen attached to this carbon here. Then there will be 3 hydrogens over here that form the methyl. So let me draw those in. Which color should I use? I'll use this color. Show the sharing of electrons in each of these that are forming the sigma bond. It's kind of hard to see those electrons, but they are there. Sorry about that. And we have just completed this hybrid orbital diagram. So not too bad, still a little bit more involved, but not too bad. So we drew in our molecule kind of in the same orientation. I drew in the oxygen, the carbon, and then the other carbon. I dealt with the sp2 hybrids first. So this oxygen has 3 sp2 hybrids. This carbon has another 3 sp2 hybrids, and they overlap here to form a sigma bond. And then they each have an unhybridized p orbital, so 2 unhybridized p orbitals total. These ones going in the plane, these out of the plane, and the 2 lobes of each p orbital overlap to form the pi bond. So 1/2 of the pi bond here, 1/2 here. I then drew in the back lobes for all of those. I drew in the third atom, which is another carbon. I drew in the 4 sp3 hybrids, a little more narrow because they have greater percent S character. 2 going in the plane, 2 going out of the plane. I then drew in my hydrogens and my electrons and labeled these as sigma bonds. And I just noticed that I forgot to put electrons right here. This was a little thing. Okay, so that is the hybrid orbital diagram for acetaldehyde, probably the most challenging you'll get or see.